In under 6 minutes, you can take a raw text manuscript and transform it into a fully rendered animated short drama. To pull this off, you only need 2 starting assets: a local installation of the Toonflow app and the raw text file of your story. You will also need 3 separate active API keys: one for a large language model to handle the narrative logic, one for an image generation model, and one for a video synthesis service. By keeping these 3 cognitive and visual engines separate, the system avoids processing everything at once. This drastically reduces the computational load on your local machine. Step 1 is getting into the system. Launch the application and log in using the default credentials: username admin, password admin123. This diagram shows a severe exploit path known as CVE 2026-7086. Because of a path traversal vulnerability in the software's export function, an attacker can bypass URL validation, access your SQLite database, and extract your entire configuration file, including the master authentication tokens. You must change the default password immediately after your first login to secure the local database against this attack. With the database locked down, navigate to the centralized settings panel. Here you will find the programmable supplier system. This interface acts as a sandbox where you can directly input the API keys for your chosen large language model, image generator, and video synthesizer. Once you secure your credentials and link these 3 foundation models, your standard desktop environment operates as an autonomous, decentralized production studio. To start production, create a new project and import the raw text of your screenplay. If you were to feed this entire manuscript directly into a language model, the system would quickly lose track of details over the long context window, leading to severe hallucinations and plot drift. To solve this, you must run the chapter event extraction protocol before the script phase. This protocol scans the text and algorithmically distills sprawling paragraphs into a clean, interconnected taxonomy. It specifically maps characters, actions, and chronologies, so the system knows exactly what happens and when. Now you can switch over to the ScriptAgent module and instruct the system to generate a formal story skeleton based on those extracted events. This chart maps the 3-layer architecture. Notice how the decision layer, handling cognitive planning, is strictly separated from the execution layer, making API calls. By keeping planning isolated and using event graphs, the system maintains precise narrative continuity across the project. Once the script is approved, switch your interface to the production agent. This opens the infinite canvas workstation, replacing a traditional linear timeline with a spatial node environment. Start by selecting a character node. Prompt your image model API to generate a character reference sheet to establish your core visual aesthetic. When you are happy with a character's design, simply draw a connection line within the canvas from that finalized character node to the blank storyboard nodes for your upcoming scenes. This chart breaks down the operational costs of a standard project, revealing why we build static storyboards first. Temporal video synthesis is incredibly expensive, accounting for over 92% of your total production budget. Since image generation is so cheap, you should aggressively iterate your image prompts here. Refine the camera angles and compositions until every static storyboard node perfectly matches your narrative flow. Executing this meticulous pre-production on the infinite canvas prevents you from paying for costly video generation calls on scenes that aren't ready. Now that your static storyboards are locked in, select those refined nodes and trigger the Video Model API to generate your temporal assets. If a resulting video clip has visual artifacts or poor pacing, the nonlinear topology of the canvas works to your advantage. You simply delete that specific video node, tweak the prompt, and regenerate it without affecting the rest of the project. Once every visual node contains a satisfactory video clip, you can initiate the final consolidation protocol. The individual assets flow backward through the dependency graph, returning to a centralized workbench state where the application executes automated splicing and applies scene transitions. By removing the constraints of a traditional linear editing timeline, you gain the ability to make rapid, modular corrections and compile your final video without friction. The result is a fully continuous animated short drama, proving the efficiency of a unified multimodal generation pipeline. We started with a secure local installation, moved through algorithmic event extraction, locked in our visuals on the infinite canvas, and consolidated the final synthesized assets. As you become more advanced, you can iteratively optimize the system's core behavior. The prompt matrices for the agents are stored as local markdown files, allowing you to edit the AI's pacing and tone without recompiling any software. This means Toonflow operates as an entirely adaptable workstation, giving you the exact tools you need to accelerate your production and scale your creative output.